find a 120 volts AC single-phase input transformer with a 3-phase secondary for simulating 3-phase motor power, there are several manufacturers and distributors you can explore. Firstly, consider looking at manufacturers such as Solar Digi-Key. They offer a range of power distribution products and transformers. Secondly, Solar Electric also provides power distribution products. Thirdly, Universal Transformer specializes in phase-shifting transformers, which may suit the need. Fourthly, Triad Magnetics offers a variety of 3-phase transformers. Moving on to distributors, firstly, Digi-Key carries a selection of 120 volts AC to 3-phase transformers. Secondly, Mouser Electronics also offers 120 volts AC to 3-phase transformers. Thirdly, Allied Electronics provides similar transformers as well. Now, considering the specifications, the input is 120 volts AC single phase. The output should be 3 phases, 6 volts AC per phase, with a capability of 3 amps per phase. The desired phase shift is near 120 degrees, allowing for a tolerance of plus or minus 10%. Several additional considerations are important to keep in mind. Firstly, it is crucial to ensure that the transformer is suitable for the specific application and meets all relevant safety standards. Secondly, it may be beneficial to use a variable transformer to adjust the output voltage if necessary. Thirdly, a voltage regulator may be used to stabilize the input voltage, ensuring consistent performance. When choosing a transformer, there are a few key specifications to verify. The input voltage is 120 volts AC single phase. The output should be 3 phases with approximately 6 volts AC per phase. The current rating for each phase should be at least 3 amps. The phase shift between each phase should be near 120 degrees, within a tolerance of plus or minus 10%. The transformer must be capable of handling the load of the test fixture. Safety certifications are important to ensure the transformer meets industry standards. It is also useful to consider the transformer's efficiency, size, and mounting options to ensure they fit the intended application. When using the transformer in a test fixture, it is important to consider a few factors. Safety is paramount, so ensure that all connections are properly insulated and that the transformer is grounded. Also, consider using fuses or circuit breakers to protect the transformer and the device under test from overcurrent conditions. Monitor the temperature of the transformer to prevent overheating. It is also useful to use a multimeter or oscilloscope to verify the output voltage and phase angles. When selecting a 3-phase transformer, consider the following. The voltage transformation ratio, which is the ratio between the input voltage 120 volts AC and the output voltage 6 volts AC. The power rating in volt amps, which indicates the transformer's capacity to deliver power without overheating. The insulation class, which specifies the maximum operating temperature of the transformer's insulation. The type of core material, which affects the transformer's efficiency and size. The winding configuration, such as delta or Y, which determines the phase relationship of the output voltages. The impedance of the transformer, which affects its ability to handle short circuits. The enclosure type, which protects the transformer from environmental factors. The weight and dimensions of the transformer, which affect its ease of installation. The certifications, such as Underwriters Laboratories or Canadian Standards Association, which ensure the transformer meets safety standards. And the manufacturer's warranty, which provides protection against defects. Phase-shifting transformers are specifically designed to alter the phase relationship between the input and output voltages. These transformers can be used in various applications such as power factor correction, harmonic filtering, and motor starting. The phase shift angle is typically expressed in degrees and can be either leading or lagging. The phase shift angle is determined by the transformer's winding configuration and core design. Phase-shifting transformers can be either single-phase or 3-phase. 3-phase phase-shifting transformers are commonly used in industrial power systems. Phase-shifting transformers can also be used to create multiple output voltages with different phase angles. This can be useful in applications such as testing motor drives or simulating unbalanced loads. When selecting a phase-shifting transformer, it is important to consider the following factors: the input voltage, the output voltage, the phase shift angle, the power rating, the efficiency, the impedance, the insulation class, the enclosure type, the weight and dimensions, the certifications, and the manufacturer's warranty. Variable transformers, also known as auto transformers, allow for continuous adjustment of the output voltage. These transformers can be used to compensate for voltage fluctuations, regulate the voltage supply to equipment, or test equipment at different voltage levels. Variable transformers typically consist of a single winding with a sliding brush that taps off a variable number of turns. The output voltage is proportional to the number of turns between the input terminal and the brush. Variable transformers can be either single-phase or three-phase. Three-phase variable transformers are commonly used in industrial applications. When selecting a variable transformer, it is important to consider the following factors: the input voltage, the output voltage range, the current rating, the power rating, the efficiency, the impedance, the insulation class, the enclosure type, the weight and dimensions, the certifications, and the manufacturer's warranty. Voltage regulators are devices that maintain a constant output voltage despite variations in the input voltage or load current. Voltage regulators can be used to protect sensitive electronic equipment from voltage fluctuations and ensure that the equipment operates correctly. There are several types of voltage regulators, including linear regulators, switching regulators, and ferrosonant regulators. Linear regulators are simple and inexpensive, but they are not very efficient. Switching regulators are more efficient than linear regulators, but they are more complex and expensive. Ferrosonant regulators are very robust and can handle large voltage fluctuations, but they are bulky and expensive. When selecting a voltage regulator, it is important to consider the following factors: the input voltage range, the output voltage, the current rating, the power rating, the efficiency, the regulation accuracy, the response time, the noise level, the protection features, the enclosure type, the weight and dimensions, the certifications, and the manufacturer's warranty. Fuses and circuit breakers are overcurrent protection devices that protect electrical circuits from damage caused by excessive current flow. Fuses are single-use devices that melt and interrupt the circuit when the current exceeds a certain level. Circuit breakers are reusable devices that trip and interrupt the circuit when the current exceeds a certain level. Fuses and circuit breakers are available in a variety of sizes and ratings to protect different types of circuits. When selecting a fuse or circuit breaker, it is important to consider the following factors: the voltage rating, the current rating, the interrupting capacity, the time current characteristic, the type of circuit being protected, the ambient temperature, the mounting method, the certifications, and the manufacturer's warranty. Multimeters are electronic test instruments used to measure voltage, current, and resistance. Multimeters are essential tools for electrical and electronics technicians. Multimeters can be either analog or digital. Digital multimeters are more accurate and easier to read than analog multimeters. Multimeters typically have a variety of features, such as auto-ranging, data hold, and continuity testing. When selecting a multimeter, it is important to consider the following factors: the voltage range, the current range, the resistance range, the accuracy, the resolution, the features, the display type, the battery life, the safety rating, the size and weight, the price, and the manufacturer's warranty. Oscilloscopes are electronic test instruments used to display and analyze waveforms. Oscilloscopes are essential tools for electrical and electronics engineers. Oscilloscopes can be either analog or digital. Digital oscilloscopes are more versatile and offer more features than analog oscilloscopes. Oscilloscopes typically have a variety of features, such as triggering, time-based control, and voltage scaling. When selecting an oscilloscope, it is important to consider the following factors: the bandwidth, the sampling rate, the memory depth, the number of channels, the triggering capabilities, the display size, the portability, the price, and the manufacturer's warranty. Grounding is the process of connecting an electrical circuit or equipment to the earth. Grounding provides a low impedance path for fault current to flow, which helps to protect people and equipment from electrical shock. Grounding is required by electrical codes in most countries. There are several types of grounding systems, including equipment grounding, system grounding, and static grounding. Equipment grounding connects the metal enclosures of electrical equipment to the earth. System grounding connects the neutral point of an electrical system to the earth. Static grounding connects objects that can accumulate static electricity to the earth. When designing a grounding system, it is important to consider the following factors: the soil resistivity, the fault current level, the equipment sensitivity, the safety requirements, the code requirements, the cost, and the maintainability. Insulation is the process of covering electrical conductors with a non-conductive material. Insulation prevents electrical current from flowing where it is not intended to flow, which helps to protect people and equipment from electrical shock. Insulation is required by electrical codes in most countries. There are several types of insulation materials, including rubber, plastic, and ceramic. The choice of insulation material depends on the voltage, current, temperature, and environmental conditions. When selecting insulation material, it is important to consider the following factors: the dielectric strength, the temperature rating, the chemical resistance, the mechanical strength, the flexibility, the cost, and the availability. Overheating can damage electrical equipment and cause fires. Overheating can be caused by a number of factors, including overloading, poor ventilation, loose connections, and defective components. To prevent overheating, it is important to follow these guidelines. Do not overload electrical circuits. Provide adequate ventilation for electrical equipment. Tighten all electrical connections. Replace defective components promptly. Use thermal monitoring devices to detect overheating. Follow the manufacturer's recommendations for operating electrical equipment. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is used by electrical inspectors to ensure that electrical installations are safe. Article 450.3 covers the overcurrent protection of transformers. It provides requirements for protecting transformers from overcurrents to prevent damage and fire hazards. These requirements depend on factors such as the transformer's size, voltage, and application.